Hello, ladies and gentlemen, it's Mr. Green again, and I'm sending you another recording. This one is over function operations. Function operations. What we're going to be doing is no longer are we just going to look at adding and subtracting numbers. We're going to now say, well, numbers can be expressed as functions, so we're going to add and subtract the functions. We're going to multiply the functions. We're going to divide the functions. It's not a difficult task because I know you guys all know how to add and subtract. It's just a matter of looking at the functions and then trying to simplify them as best we can. Then we're going to look at the domain and range of some functions and see what we come up with. Okay, so let me just define a couple things for you. When you see this here where it says, come on, pointer, right here where it says f plus g of x, what it's asking you to do is to find f of x plus g of x. Okay, that seems pretty straightforward. Subtraction works the same way. F minus g of x is f of x minus g of x. Okay, we can do that. When we see fg of x, what it's asking for is f of x times g of x. Okay, pretty straightforward stuff. I think we can handle this, Mr. Green. F of x, f divided by g of x is going to be f of x divided by g of x. And the only caveat here is that g of x can't be equal to 0. That means that's going to affect the domain. You got to look for anything that would cause that to be a 0. So you would say the domain doesn't include that value. Okay? So let's go on and see if we can't look at a couple of problems here. What you would be looking at. If I were asking you to find the sum, the difference, the product, and the quotient, what am I saying? Add them together, subtract them, find their product, and also find the difference. So let's look at f plus g of x. Okay? So f of x is x squared minus 4. G of x, I'm going to add that on, x minus 2. Okay, go off my pad. X minus 2. Well, I can see the 4 and the 2 can be added together, can't I? And so what am I going to wind up with? That's going to be x squared plus x minus 6. Well, you know what? I think that I could actually factor that. That would be equal to x minus 3, x plus 3, x minus 2 would be the factor of that. Why did I factor it? Sometimes when you do these things, they're going to list the answers this way. Sometimes they're going to list the answers this way. Which way are you going to see it most often? Don't know. It depends upon the problem and how they're writing it. Now, if we're just doing addition, it's probably going to be this way. Okay? But just so that you know, it could have been factored, and this is what I wound up with over here. They could ask you, what are the roots of f plus g? And then by doing it this way, you would know my roots are at -3 and 2. Okay? So let's go on. Let's find the difference. F minus g of x. Well, that's going to be equal to x squared minus 4 minus x plus 2. Where'd you get the plus 2, Mr. Green? Well, remember, it's actually x minus 2, and I have to subtract the whole thing. So I'm simply distributing the minus sign to both these, and I have a minus 2. That's where the plus 2 came from. And so this is equal to x squared minus x minus 2. Well, this one factors as well. And this one's going to factor into x, and then a minus 2 and a plus 1. Mr. Green, these aren't the same. Did you expect the product, the sum, and the difference to be the same? No, not really. But I do see how you're factoring it to this. And if you don't believe me, do use the FOIL method. Make certain I'm multiplying it back out right. Otherwise, come and tell me in Toga somewhere. But that's the whole point, is I'm trying to see what the difference between them is. I'm trying to see what the sum is. I'm trying to see what the difference is. And then just compare these two to see if there's anything that I could be looking for. Okay, so far factoring hasn't helped me a whole lot. But let's look at the product. If I say the f of g, and I'm just multiplying those together, of x is equal to x squared minus 4, parenthesis, times x minus 2. Well, this first one is what's called a difference of squares, and it's one of those things that you start to recognize after a while. It factors into x minus 2 times x plus 2, and then we've got also x minus 2, and I notice I've got two of those, and so my ultimate answer would be x minus 2 squared times x plus 2. If you want to square this whole thing out and see what you would wind up with, well, FOIL method here, you're going to get x cubed minus 4x minus 2x squared and a plus 8. Cool. Now, so far, no biggie. We're just doing what we see to do here. Let's try the f divided by g of x and see what we wind up with. Well, f of x is, once again, this x squared minus 4 divided by x minus 2. I've already said that that's a difference of squares on top, so that's x minus 2 times x plus 2 divided by x minus 2. And I can see that this cancels into this, and so what am I left with? X plus 2. And that's my total answer. So what did I get? I got 4 different answers here. Well, we didn't expect anything different from that, did we? Not really. Okay? But I want you to see that by getting 4 different answers, by doing this, you shouldn't get the same things when you're adding, you're subtracting, you're multiplying, and you're dividing. You just have to know how to do them to make them work out right. Correct? Okay, I've shown you how those are worked. Let's try a couple more. So we've got f of x is x squared plus 7x plus 12, and g of x is x plus 4. I'm going to find the sum. F plus g of x is going to be x squared plus 8x plus 16. I didn't write them both down. I just went ahead and added the x to the x, got 8x, added the 4 to the 12, and got 16. Yes, that does factor into x plus 4 quantity squared. Cool, I found the sum. Let's find the difference. F minus g times x is going to be equal to x squared plus 6x plus 8. What did I do? I subtracted the x from the 7, I got 6x. I subtracted the 4 from the 12 and got 8. And yes, that does factor as well. What do we factor that into? X, 4 and 2, yep, plus 4 plus 2. Okay? Now, guys, don't feel bad if you're not good at factoring yet. We will get more practice at doing this, and I'm just showing you I'm doing them quickly here because this would be considered a right answer here, as well as this. If you know how to factor it, it helps you when you're doing the division. Does it help you on any of the others? Not really. I'm just showing you how it's done. I'm trying to model it for you so in the future you'll know. So f times g of x is equal to, well, I'm going to be multiplying them together. So the first thing I'm going to do is I'm going to make certain I factor this first one, and that's 3 times 4. Okay? So that's going to be x plus 3 x plus 4. And then we're also multiplying it times an x plus 4. And so my ultimate answer over here would be x plus 4 quantity squared times x plus 3. Now I could have expanded that out as well. I would have to take the x times every one of the values in the f function, and I would get an x cubed plus 7x squared plus 12x, and then the 4 times every one of them plus 4x squared plus 28x plus 48. And when I add those two things together, I get 48. 12 plus 28 would be 30, 40. X. 7 plus 4 would be 11. X squared. And then the x cubed at the top. Okay? Last one. F divided by g of x is going to be equal to, I'm going to use this factored form here because that's going to be x plus 3, x plus 4 divided by x plus 4. These are going to cancel each other out, and my answer is going to be x plus 3. Okay? Would this be wrong? Not entirely. But the simplified form would be this. It's like taking a fraction and not finding the simplified form. Would this be defined everywhere? No. You would have to say everywhere except for when x is not equal to negative 4. Why? Because I got a 0 down here on the bottom, didn't I? But even though I simplified it, I'd still need to say that my domain needs to have that value excluded from it. Okay? Moving forward. This one says, determine the domain of f divided by g of x for f of x is equal to this and g of x is equal to this. I don't need to do anything about trying to combine these or factor them or anything else, because all I'm looking for is the domain. And in the domain, I can't have the g be equal to 0. So what am I going to do? I'm going to find when it is equal to 0. I'm going to say that 0 equals the square root of 9 minus x squared. Okay? Squaring both sides of the equation, I get 0 is equal to 9 minus x squared. Adding an x squared to both sides, I get an x squared is equal to 9. 9. Taking the square root, I get that x is equal to the plus or minus 3. Why? Because positive 3 or negative 3 would give me a 9 in that situation. I cannot have my value being anything like plus or minus 3. Now another thing I need to look for is I can't have anything negative under the square root sign, can I? So I can't actually have it be anything greater than that or less than that. So x cannot be greater than negative 3, greater than positive 3, and it cannot be less than negative 3. Why do I say that it can't be any of those values? X has to be defined in this tight little range. If I had a 4 for x, I would have 9 minus 16. That would give me a negative number under the square root, and that's not a real solution. I can't take the square root of a negative number. Try it on your calculator. They don't like it. Okay? So what I would be looking for there is that my domain would be defined as x greater than or equal to negative 3, less than or equal to negative 3. If you wanted to write that in set notation, it'd be negative 3, comma 3 with brackets, close brackets at both ends. Okay? Moving forward. Do not forget to tell me that you're in Algebra 2 when you're talking to me. I cover some of the same topics in pre-cal. If you ask me, I go a little bit faster with my pre-cal students, and so you would be lost real quickly. I would prefer to slow down and make certain you're understanding what I'm talking about, and so you need to make certain you're telling me that you're in Algebra 2 so that we can keep track of where you are. Okay, I'll see you next class period.